In this part, we will still continue to learn the compound and continuous interest. We have the formula for the compound interest, the continuous interest, and when we studied exponential functions, right? So now we will continue this topic. So here I just give you a quick review for the compound interest and continuous interest. So the compound interest, the formula is A is the future money, P is the present money, sometimes we call it principal, times 1 plus R is the annual rate over M. M is the compound period, okay, per year. How many compound periods per year? If compound quarterly, M equals 4, right? If compound annually, then N equals 2. If compound annually, and M equals 1. Compound semi-annually, compound M equals 2, right? So this is the M times T. And this is the continuous interest. The formula is A times P times e to the RT. Okay, so here R is the annual rate, and the P is the principal or the present money, present value, and the A is the future money and future value, and the T is the how many years, in years. Okay, so let's look at some examples. So last time when we studied the compound interest and the continuous interest, we only calculate the future money. So now our problem becomes complicated. If we know the future money, and we know the annual rate and the compound period, and we know the time, what is the current money we should invest or we should deposit to get this future money? Okay, so this is the next example. Okay, so in this example, how much should new parents invest at 8% annual rate to have $80,000 toward their child's college education in 17 years? If the interest is the first problem, if the interest is compound semi-annually. So now let's look at the first one. Compound semi-annually. Okay, so we use our formula. So A is equal to P times 1 plus R over M to the M times T, right? To the M times T. So now, this A is given. A is 80,000. R is 8%, which is 0.08. M, because it's semi-annually, so M equals 2. You have 2 compound periods. And the T, 17 years, so T equals 17. So we have everything except P. So the question is how much the new parents should invest, right? So it asks you the present value. So let's plug in everything, right? This is 80,000 equals P, we don't know, 1 plus 0.08 divided by 2. This is 2 times 17, okay? Let's do the calculation. So this is P, this is the 0 0.08 divided by 2, which is 0.04 plus 1, so it's 1.04 to the, what's the power? 2 times 17, 34. So P is equal to 80,000 divided by 1.04 to the 34. So when you use a calculator, you need to calculate this term first, right? You need to calculate this term first. So if you use a calculator, you will have 80,000 divided by, keep as many decimals as possible, okay? So 3.794316341. Okay, so when you do the division, so you will have 21084.16716. Okay, so in general, for the money, we will round it to the 2 decimals. So this would be 1,21084.14 dollars. So this is the part A. The part B says if the interest is compound continuously. Okay, so we use the continuous compound continuous interest, continuous compound interest. The second part B. The formula is A equals P times E to the R times T. So now we know A is equal to 80,000 and R equals 8%, which is 0.08. T equals 17. Okay, so T must be in years. Okay, so you will have 80,000 equals P times E to the 0.08 times 17. So which is 80,000 equals P times E to the, we take the product, this would be 1.36. So P is equal to 80,000 divided by E to the 1.36. So we do the calculation for the E to the 1.36 using a calculator. It would be 3.8961933302. So you see, I keep as many decimals as possible in my calculator. Okay, so this, if you do the divisions, this would be 2053.68216. So if we want to round it to the cents, so 2 decimals, so that would be 2053.32. Sorry, here I made a mistake. Here is a 2, then 0.36 dollars. Now let's look at this example. How long will it take $6,000 to grow to $8,600 if it is invested at 9.6% compounded continuously? So now it asks you to find the time t. Right, so since this is the compound continuously, so that means we need to use the compound continuous interest formula. This is P, A equals P times E to the RT. Okay, so now we know A is equal to 8,600 and P is equal to 6,000 and R equal to 9.6%, which is 0.096. So we want to find the t. So for this kind of problem, if you need to find the time, then we need some knowledge of nature log, or the logarithmic function, logarithm, okay? We need to know some knowledge of the logarithm. So here, let's plug in everything. So this is the A600 equals 6,000 times e to the 0.096t. Okay, so now let's divide by 6,000 on both sides. So this would be, so we simplify a little bit, right? This would be the 86 divided by 60. Okay, if you want to keep this 0, 0, that's fine. So this would be equal to e to the 0.096 times t. So we want to calculate the t, right? Solve for t, but our t is in the exponent, in the power position, right? So what we should bring down this t, right? So the idea is we take the natural log, then use the properties of the logarithm. So we take the natural log on both sides. Since these two are the same, so we take the natural log on both sides. What's the natural log? The natural log is the logarithm to the base e, right? So the natural log A600, of course you can simplify it. For this one, you can divide it by 100 on the top and the bottom, right? It becomes 86 divided by over 60, right? So we take the natural log e to the 0.0. Right? Then we can go back to look at when we study the logarithmic function, we have some properties for the logarithm. This says you can bring down this power in front of the natural log, 0.096t times natural log of e. So natural log of e, natural log is e, which is the log to the base e of e, right? So this will give you 1. Natural log of e equals 1. So this is the natural log A600 over 6000 divided by 0.096 times t times 1, right? So t is equal to natural log A000 6000 over 0.096. If you do the calculation, if you use a calculator to compute the top, the natural log of this fraction, so that would be 0.360002734. So as I said, you need to keep as many decimals as possible to get an accurate final answer, right? And to divide by 0.06. So it would be 3.75002849. Okay, so if the problem asks you to keep the 2 decimals, then this would be the 3.75 years. Okay, so you can see for this kind of problem, if you are looking for the t, so most case you will have to take the natural log to bring down this t in front of the natural log. Okay, so this is a very important technique for this step. I use the red color to emphasize. Take the natural log on both sides to solve this simple exponential equation. So now let's look at the next one. We still use the same technique. to solve the exponential equation.